Morning, morning, guys. Lesson 12.2 today. Today we're multiplying and dividing those rational functions. Remember, all they are disgusting fractions. And when we're done with this lesson here, hopefully today's easier than yesterday, but you should complete your 12.2 try on your own, and tomorrow we will hammer out lesson 12.3, which is solving rational functions. And then we have a formative assessment on Friday we're going to ask you to do while you're at home. Warm up, individual, multiply or divide the following, state restrictions if necessary. Well, a little common phrase I like to use, and that is simplify before you multiply. So I'm going to reduce my 2's to a 1, multiply the top, I get 1 over, multiply the bottom, I get 1 over 9. Now, number 2 is a little bit different because I don't divide fractions. We multiply by the reciprocal of the second one. And I'm going to change it like that, and then I'm going to simplify before I multiply. Well, there is a common factor of 2. I can reduce that 4 with a 14 by a factor of 2. This is going to give me 2 times 10. 2 times 5 is 10. 7 times 7 is 49. 10 over 49 does not reduce, so I am done. When I come to number 3 here, number 3, ooh, these have letters in them now. Well, now I need to see what can I reduce. So I need to factor them out. I can see there's a common factor of an x, or negative x at the top, over a negative 5x here. I can see these negatives reduce. This is going to equal x plus 5 over 5x. That's a whole factor of x plus 5. And it says list restrictions. X cannot equal 0. Because that makes it undefined, and that is my function there, my reduced one. Well, the second one, these 2 minus x looks like x minus 2, but they're a little bit different. And if I factor a negative out here, I actually get negative 2 plus x over x minus 2. And if I rewrite that top one so it makes sense to you, well, that's really an x minus 2 over an x minus 2. And I can see that x minus 2 reduces, and all I'm left with is negative 1. Now my restrictions, remember, x can never equal 2. And that is what I did in my warm-up. All right? And as I cruise along here, consider method A compared to method B in both columns. Well, take a look at them, study them, explain the differences between the two methods. Well, method A is the way you don't want to do things, is just multiply everything across. Method B simplifies before you multiply. Okay? Which method do you prefer? I prefer method B. Why? It's easier, it's faster. Simplify before you multiply. That's what I like to do. Makes life easier. Okay, so what are we going to do here? Explain how Aisha could have multiplied the rational function more efficiently. Well, what she could have done is taken her 12x, y, z squared over 11 times 33x over 8z. And what she could have done more efficiently was she could have seen this z gets rid of that guy, and this 8 will reduce with 12. Common factor in there is going to be 4, so that 8 is now a 2. That 12 is a 3. This 11 will reduce with the 33 to a 3. And what's left in the top? Well, I got 3 times x times y times z times x times 3 times x. What does that give me? That gives me 9x squared y times z over 2. And that's what she could have done easier. If you simplify before you multiply, you are reducing smaller numbers, all right? Complete the same problem by simplifying first. Well, this one looks a little bit different. Rather than multiplying, what we're going to do is we are going to completely factor both top and bottom. And this is going to give me a 3 times an x squared minus 25 times, there's a common factor of a 3 up there with an x minus 5, over a 4 times x squared I am not done yet because that's going to factor further. So usually I would factor a little bit differently, but I'll show you. 5x squared, this is going to be over 3 times x plus 5 times x minus 5 times 3 times x minus 5 over 4x squared. Usually that fuchsia one's the one I would do. I would typically see down here, this is 3 times x squared minus 25. And then I bada bing, bada boom to there, skip over this one. But then I'm going to completely factor everything. Then what I'm going to do is I'm going to simplify before I multiply. And I can see this x minus 5 cancels out this x minus 5. All right. I can see this x squared gets rid of this x squared. I can see this 3 cancels out that 3. And all I'm left with was 5 in the top because I've got a 1. With everything I cancel out turns into a 1. So I got 5 times 1 on the top. In the bottom I got 4 times x plus 5 in the bottom. And I should also list my restrictions that I have going on here, all right? And my restrictions are x can never equal, well, look back to where before I started reducing anything, okay? I can't be -5, I can't be 5, and I also can't be 0. So that is my simplified fraction. And if I can't plug these numbers, these restrictions, in the beginning, I can't plug them in the end, all right? So we're going to move along here. We're going to multiply each expression. And what we are going to do is, it's probably easier looking here. Everything's completely factored because I have no sums or differences in the top of this fraction. So, excuse me, what I'm going to do is, I'm going to say, well, A cannot be 0, B cannot be 0, C cannot be 0, looking at my original function, because they're in the denominator, they'll make either one of those fractions undefined. So these are my restrictions. And then I'm just going to reduce. I can see this A gets rid of this A, this B gets rid of that squared, this C gets rid of that squared, this 2 turns into a 1, turns this to a 2, this 3 will turn into a 1, and I'll make that 27 into a 9. And what's left at the top is 1 times B times C, so I get a BC over 2 times 9 over 18, where A is unequal to 0, B is unequal to 0, and C is unequal to 0. And you might be saying, how come they have to restrict? Well, this is equivalent to what's above, and if I can't put these values for A, B, or C in the original function, I certainly can't put them in my simplified function, all right? So I'm going to do one more here, and then I'm going to let you do the next 2. So what we want to do in number 2 is we want to factor everything. We're going to say 3x over, there's a common factor of a 5, x minus 3 times x minus 3 in the top over 9 times x squared. I don't need to separate those with the dot, but sometimes it helps. Then I'm going to simplify before I multiply because it's easier. So I'm going to say u cancel u cancel one of u go away to 1, you make that 9, 3. Check it out, there's only 1 in the top. I get 1 over 5 times 3 times x in the bottom, so I should get a 15x left over there. And then I need to list my restrictions. X could never equal. Restrictions come from the beginning. X cannot be 3. X cannot be 0. So those should be my only restrictions, and that is my simplified function. Okay? Factor, reduce, list restrictions, but make sure you list them all. So what I'm going to do is I'm going to hit pause. Why don't you give number 3 and 4 a try here? So with number 3 there, what I did was I factored the bottom, right? You know, originally I'm looking at every one of these like this, and then I'm factoring because it starts out as a factor. Well, x plus 5 doesn't factor, but this quadratic does, that x minus 3, x plus x minus 3, x minus 1. and x minus 3 up here does not factor, but there is a GCF of 4 that I'm going to pull out of there, so I factored out. It's an intelligent thing now to look at your function, list your restrictions that you have right now so you don't forget at the end, come back, now reduce common factors, and then all I'm left with was a 1 over 4 times an x minus 1, and then relist your restrictions and circle your answers, okay? Great way to go about it there. And when I'm looking at this next one, it looks pretty easy, so what I'm doing right out of the blocks, okay, I'm looking ahead, I'm like, ooh, there's a GCF here, and I'm going to be left with a quadratic, and I got a cubic here, so I'm pulling that GCF of an x out to see if I can factor that further, and I'm just saving myself a little time. So I'm taking my GCF of 7 out of there. There's no sum or difference here, so that's already, I could put a multiplication between there as 2 different factors. The top is hugged, so it's an x minus 5. The bottom I started factoring, and there's a difference of squares. That's where my plus and minus 1 come from. Top's quadratic goes to x minus 6, x plus 1. Please remember you multiply these together to make sure you match your middle term, make sure you're doing them right. Then I have an x that I listed, and then I got to factor that quadratic to an x plus 5 and an x plus 1. Then I'm looking at my restrictions. I'm like, that one's a 0. That's a negative 1. That's a positive 1 restriction. That's a 0. But I don't need to list it twice. That's a negative 5. That's a negative 1, but I already listed it, so I don't need to list it twice. And I write out my restrictions over here. Then I come back and I reduce. I'm like, oh, there's an x minus 1, there's an x minus 1. There's an x plus 5, there's an x plus 5. There's an x plus 1, there's an x plus 1. And I'm looking. There's nothing to reduce with the 7 in the bottom. There's nothing to reduce with the x minus 6 in the bottom. So the top, I should have 7 times x minus 6. And in the bottom, I should have 9x squared times, or 3x squared times 9 times x. That's where my 27x cubed comes from, times x plus 1. And then I just relist my restrictions so I can see everything that's going on there, all right? Then we are moving along here. Hopefully this is making sense. Then recall the divide fractions. You multiply the dividend by the multiplicative inverse of the divisor. Okay, well, let's look at example 1 and let's look at example 2. Analyze the examples shown in the table and explain the process for dividing rational expressions. Well, it's pretty easy. Do not divide. You multiply by the reciprocal. You don't divide fractions. We do not divide fractions. We multiply by the reciprocal. All right? So notice, this was 6 over 7 divided by 4 over 1. Well, that's 6 over 7 times 1 over 4. Then I do what I just got done doing on all those previous problems, all right? So let's move right along here. And, well, now things are a little bit different, too. Determine the quotients for each expression. List the restrictions for the variable. Well, something a little wonky's coming here. And when I'm looking at this, well, I'm thinking restriction. Okay? When I'm thinking restriction, I'm thinking A cannot equal 0, B cannot equal 0. Okay? Because they're in the denominator. Ooh, but I'm multiplying. Okay, well, let's rework this. This is going to be, so when I rewrite this, I'm like, okay, this is 9AB squared over 4 times, well, now the 5AB is in the top. There's still restrictions because it's still equivalent to this. And this 18C squared comes downstairs. Ooh, I see another restriction. C cannot be 0. So I had to add that restriction because I flipped one of those fractions. Then I am going to reduce. And when I reduce, I'm like, well, however you want to do it, I see, well, there's no C's in the top. This 18 will go to a 2. It'll turn that 9 into a 1. And this 4 does not reduce with the 1 or the 5. So I'm thinking I have 1 times a times b squared times 5 times a times b, thinking that's going to give me 5a squared b cubed over 8c squared. That is what, and then I look at that, no common factors in the top. Then I'm going to say a cannot be 0, b cannot be 0, c cannot be 0, and I am going to list my restrictions with my final answer, all right? So then I'm going to do one more with you here, all right? And there's 2 ways to skin a cat. So when I'm thinking of skinning cats, okay, I'm thinking, oh boy, there's the greatest common factor of a 3 that's going to come out of there. And that's going to, difference of squares. And here I see a 3 times an x minus 3. And I'm thinking restrictions. So right now, I'm thinking 7x squared over 3 times x plus 3 times x minus 3. And I'm going to leave this division symbol here yet for a second. I'm going to say this is 3x minus 3 over 4x squared. And I'm thinking restrictions. My restrictions are x cannot be negative 3, positive 3, positive 3, and it's listed there. Oh, wait a minute here. That's division. We don't divide fractions. Let's think about this again. So this is 7x squared over 3x plus 3, x minus 3. And now I'm going to change this to, I got to flip it, 3 over x minus 3, 4x squared. It can't be 0. I need to add that to my list now, all right? Now that I've completely factored, I've listed my restrictions, and it's important to know you're restricting everything of the fraction that's getting flipped, both top and bottom. If the fraction is not flipping, you just restrict the values in the denominator. I like to list my restrictions first, and then I like to come back and say, okay, now I'm going to simplify before I multiply, and I see you go away, I see you go away, I see that 3 goes away, 7 and 4 won't reduce. I'm just left with a 7 in the top and an x plus 3 in the bottom, and my restrictions, then I'm going to come back and say, x can never equal negative 3, 0, or 3. And that's why I'm listing them in numerical order, because I'm seeing them, I'm seeing them right out of the blocks, and then I can rewrite them appropriately when I circle my answer. And, oh boy, Krooks, you almost forgot your 4 that was down there. That 4 never reduced. So don't forget it. You got to make sure everything that was not reduced stays in there. So why don't you give number 3 and 4 a try, and I am going to be back in a minute. Okay, so I give this a quick look over, and I'm like, oh, I got a cubic in the denominator of this one, so I know I'm pulling a GCF of x out, so I got a little head start there. And I completely factored everything, and that's all I did. Notice I didn't do any flipping of anything yet, all right? So I factored the top, GCF of 4. Nothing factors there because it's 5 times. I gave that x plus 6 a hug. There was no GCF or anything in there. I'm like, ooh, a difference of squares, x plus 4, x minus 4. And I left my division here. And I'm doing that so my virtual students can see that when I factor this all out, when I'm looking at my restrictions, okay, I'm like, okay, I got a restriction of 0. I got one of negative 4. I got a restriction of 4. That 0's been listed. That 4's been listed. And I got a restriction of 3. And then I'm like, question mark. No, I don't divide fractions. I multiply by the reciprocal. So then I come down and I just rewrite it all. Notice these first 2, they stayed the same, but I changed that to multiplication and I flipped these guys over. And then I'm like, whoa, I got new factors in the denominator. I also can't have a 6, that's not my list, so I got to add it. And I also can't have a positive 1, and that's not in my list of restrictions, so I got to add that. That's a pile of restrictions. Then I come back after everything is changed to multiplication and it's factored. Now I'm like, an x minus 1 gets rid of an x minus 1. And where am I looking? Where am I looking? An x plus 4 gets rid of an x plus 4. This x is going to get rid of one of those guys there. And that's an x plus 6, and that's an x minus 3. Oh, that's a number 4. Oh man, I jumped past number 3. We're going to go back to number 3. And sorry about that. And so then as I'm cruising down here, I don't even know if I wrote my final answer down here for this one. Anything else produced? I don't think so, because a plus 6 and a minus 6 are different. And so I look at the top, so I got my 4, I got my x plus 6, I got my x minus 3 in the top, and I got a 5x in the bottom. I got a x minus 4 in the bottom. I got an x minus 6 in the bottom. Nothing else reduced. And then I just relisted my restrictions, and I put them in order. They don't have to be in order, but they all need to be listed, all right? Now, let's get this bugger going up here. Let's go back to number 3. Sorry about that. I kind of got a little wonky there. But I'm looking, and my eyes skim through, and I have really no GCFs that are coming through other than here, but I see they're all coming out. So I factored everything. And I left my 3x plus x plus 5 back to the bottom of that quadratic right there, turned to x minus 8, x plus 5, and I did not flip that. I left it for a reason, but I did factor that denominator so I could come over and I could say list my restrictions here now, because I got a 8 that needs to be restricted, a negative 5 that needs to be restricted, a negative 8 that needs to be restricted. I'm like, 8, oh, okay, I've listed you already, don't need to do it again. Then I'm like, do we divide fractions? Absolutely not. We multiply by the reciprocal. So I'm going to change my division to multiplication, and I'm going to flip the fraction that's getting divided, and I'm like, whoa, new factor in the denominator, of which 0 is not in my list, so I got to list it. Then, now I get out my hack and slash number. I'm like, x minus 5, x minus 5. This x gets rid of one of those. This x minus 8 eliminates that x minus 8. And in the top, I can see I have 3 times x plus 8 over 5 times x only. And then I put a comma, list my restrictions of negative 8, negative 5, 0, and 8. And I just put them in a numerical order for you to get number 3 done. Okay, so what do? You factor, flip, reduce when you're dividing fractions. Okay, and then what do we got for the rest of the day? Hey, you just got your homework to do today, and we will be back for a video yet tomorrow. So make sure you get these done, and tomorrow we will be solving rational expressions where my restrictions become very, very important. Hey, you guys have a great day. We'll talk to you tomorrow.